Here you have an equation in which you have variables on both sides of the equal sign. The first thing that you have to do to solve for x is to isolate the x. You have to combine like terms to get the x by itself. All right, so notice you have a 3x and you have a 2x. I have to combine these. So that means one of them I have to move to the opposite side. The way that you decide which one is by selecting the smallest one. 2x is smaller than 3x, so I'm going to move the 2x to the other side. Well, are you going to add 2x or are you going to subtract 2x? Notice that's a positive 2x, so you always do the opposite of what you see. So you are going to subtract 2x from both sides. 3x minus 2x is 1x. I'm going to rewrite the problem to keep from messing up. 2x minus 2x is 0, so that cancels out. So you're left with x plus 4 equals 7. Subtract 4 from both sides because you always do the opposite of what you see. 7 minus 4 is 3. So x equals 3. Now, one of the ways that you know if your answer is right is by plugging the answer back into the original problem to see if both sides check. So every time I see an x, I should plug in the number 3. So this means 3 times 3, which is 9, 9 plus 4, which is 13. So the left side of the equal sign is equivalent to the number 13. Let's check out the right side. 2 times 3 is 6. 6 plus 7 is also 13. So I know my answer is right because it checks. Let's try a different problem. Here, if I give you negative 6x plus 8 equals 9x minus 7. You're going to do this the same way. You have to combine the x's together. So first you have to decide negative 6x, 9x, which is smaller. The negative 6x is smaller, so instead of subtracting, I'm going to add 6x to the other side because you always do the opposite of what you see. Negative 6x plus 6x is 0, so that's gone. So let me rewrite the problem. 8 equals 9x plus 6x is 15x minus 7. So I add 7 to both sides because you always do the opposite of what you see. So 15x equals 15. My pen is not working correctly, but that's okay. Divide both sides by 15 because you always do the opposite of what you see. 15 divided by 15 is 1. So here, x equals 1. Now, if you look in your textbook, this is lesson 2. In unit 2, you'll notice, or lesson 2 in the book, excuse me, that there are some sample problems in which you'll have parentheses in the problem. Remember, you always start with distribution, in which you will distribute everything that's on the outside to whatever's on the inside. Before we conclude, let's try one of those examples. So you have 5 times the quantity of x minus 2 equals 3x, or 3 times the quantity of x plus 4. So before we could even solve this, you would have to use the distributive property. Whatever's on the outside of the parenthesis, you multiply it times everything on the inside. Here's what I mean. You would have 5 times x, which is 5x, and you would have 5 times negative 2, which is negative 10. Other side, you would have 3 times x, which is 3x, and you would have 3 times 4, which is 12. So you would solve this like normal. Subtract 3x from both sides. So 2x minus 10 equals 12. Because the 3 is canceled, 3x minus 3x is 0. Add 10 to both sides. Two x equals 22. And x equals 11. How do we get 11? Because I divided 2 on both sides. Remember, you always do the opposite of what you see.